Here we've got a friend's guitar amp. It's a Fender Hot Rod DeVille 212. So he says it kind of works, but is very noisy. Some crackly noises and that kind of thing. So let's see if we can find out what's wrong with it. Okay, so let it warm up. Just see how it sounds with no input. Okay, got some hum out of it now. Okay, so the volume pot is noisy. As are the others. Oh, and it seems to be something like when there's an impulse, it seems to hit the reverb or something like that. Let's see. That knob just spins. Interesting. And there's certainly a fair bit of hum there. Although not too much hum when the volume's right down. Okay, let's take the back off and have a poke around. So I've taken out the first valve, so we're getting a little bit less noise pickup from the first stage, but still a fair bit of hum, particularly on one of the channels. Well, hum and extra noise. And when I do hear something, whether it's the microphony from hitting things or some random impulses, it does seem to be reverbing, and I've taken off this pot control here and noticed that, well, it's a bit noisy, yes, but they all are. But more importantly, it's just spinning round. There's no end stop. So when I'm trying to cut the reverb to minimum, I mean, it's just, I think it's not doing anything. I think something must be broken in there. I'm going to have to get that out and have a look, see what's happening. I was inclined to do that anyway, just to clean all the pots. I think that's inevitable. Not super easy, not super hard, I suppose. I did check the capacitors here, the main capacitors. They looked visually okay, no leakage, and I tested with a meter. The capacitance is good, and by an ohm or so ESR, so that's quite acceptable, I think. I haven't checked any of the smaller ones yet, though. But certainly these radial ones, I'm going to have to get the board out to connect to the other side anyway. Oh, hello. Oh, that's a bit suspicious. Ah, could we have a dry joint on that capacitor? Well, could be worth investigating when I get the board out. Yes, I think that's it. I'm going to get the board out and look at the connections, the pots, and go from there. So with a bit of difficulty, I've managed to take the board out. As you can see, there's not much clearance at the top by the chassis. These pots foul on the top. Another centimetre would have made it much easier, but if you remove the cables on the far side, you can just about do it. A couple of things to note straight away. This potentiometer seems to have been replaced at some point the sign of flux on the board here, which looks like a manual soldering job that somebody hasn't cleaned after. So I'm going to take these out anyway to clean them and put lubricant and cleaner on, but that's just something of note. These connections here to the input jacks are going to be remade. They're very suspicious. I mean, it's always a good idea to check and remake this kind of thing where there's any kind of physical action. This one looks a little bit bad. You probably can't see on the camera, but I've got a lens here which I've looked through, and this socket here is noticeably more wobbly than this one, and in fact I can just see the connections there just moving. There's just not a good joint there at all. If the focus will work, there we go. So that's definitely going to be a problem. That's going to make a poor connection on that jack socket. Moving over to the far left, similarly these look a bit suspicious. Not as bad, but certainly I will remake these connections. I had a quick look at the capacitor that was a bit iffy on the other side when I touched it and prodded it. These connections don't look dry. They look pretty good to me visually. I guess I'll remake them and just see if that helps or not. Maybe there's a problem inside the capacitor that's warranting a replacement. You know, I'm in two minds whether to replace those capacitors anyway while I've got everything apart. Anyway, we'll see. That's the next job. Do those, remove these pots, clean them, and I've got to look at this reverb pot as well. There's a special case of possible fault there. So this is the potentiometer for the reverb, and you can see that there's too much play here. This plastic top just unclips from this metal here, just slots in there, and it seems to not bed down properly, so I'm just going to put it on, tap it with lightly with a hammer kind of thing to push it in a bit further, and hopefully that will be okay. Yep, so that seems to have done the trick. It's now in a better position lower down. So just need to clean it, put the back on, and we'll test it out. While I'm here, just note that this connection block for the loudspeaker was flopping around in the breeze. The rivet head that's supposed to hold it on had just come off at some point, so I've just glued that back on. And also this second speaker, although the rivet head was still there, it was rotating, so I've just put a dab of glue on there just to keep it firm. Some people have reported that this first preamp valve is too high gain, and the volume is sort of compressed. The usable range is compressed at the bottom there. I'll have to ask my friend when he's testing whether that's a problem for him, but apart from changing the valve, I did look at the circuit, and there's a couple of obvious things you could do. So here we've got R5 as the DC bias point, which is then decoupled by this C1 47 microfarad to increase the gain at audio at AC. So an obvious addition or modification would be to put a resistor in series with this capacitor to reduce the gain at AC at audio without affecting the DC point. So I don't know, just sort of guessing, I might try like a 500 ohm or a few hundred ohms in series with this C1, and that would reduce the gain. On the board here, that's C1, so that's one option. The other option is around the volume control. So here, after this first stage, DC blocker goes into a potential divider, part of which is the volume control. So even here, all of the volume range is not available because of this 220. And if you want to modify that range, we could increase this resistance here and make the signal available, or signal range available at the volume control less, which means you'd have to turn up the volume control more, so you'd have that shift in range. So again, some trial and error probably is required, but if that's 220 compared to 250, that's almost half and half. So maybe add another few hundred K to that resistor, R9. R9 is that one there. So this has been on for several minutes, just normal mains hum, nothing excessive, no surface noise, kind of strange effects. The pots are relatively quiet. The treble was one point where it was still a little bit noisy, but that seems to even have gone now. So I'm pretty happy with this. Pity I can't play the guitar, but anyway, I'll give this back to my friend, and hopefully it will last quite a while. So the amp's been on for a few minutes just to warm up, and I'm going to have a look at the biasing. So there's a test point here, 60 millivolts, which is this point here between the two output valves. So that sets the DC bias point across that resistor to ground. So 60 millivolts should be here on that point there. Now it's a little bit high, and we may want to adjust that pot there. However, before that, I'm going to get my auto transformer out and set the mains input to the nominal 230, because here my mains tends to be a bit high, so that might be why this reading is a bit high. Yeah, so my mains here is running at 240, sometimes it's up to 250, so it's a little bit on the high side, but let me just reduce that down to the nominal 230. There we go. So now I'll have another go and look at the bias voltage. So with the auto transformer now delivering 230 volts mains input nominal, we're getting a more reasonable 64 millivolts, which is probably not worth playing with, but maybe I'll just make a small adjustment to see how sensitive that control is. Yeah, I just tried changing it, and it's pretty sensitive. Tiny amount of change alters the voltage by several millivolts. So, well, it's now nearer 60, but I think it'll be very dependent on the mains voltage anyway, so it can't be very critical. So I mentioned the first amplifier is sometimes considered too high gain with the stock 12AX7, which is an ECC83 equivalent. So I did order another valve, a 12AU7, which I believe is an ECC82 lower gain, partly for testing purposes, because I thought one of the valves might be noisy, and this one was lower gain and was considerably cheaper than the ECC83. So I got this delivered for I think about £8 or something. I have put it in. Indeed, it is lower gain, so it gives you a broader range on the volume control at the lower levels. So you might want to try that, something like that, if that's something you will find useful. So I guess my friend's got a spare now, and he can swap them according to his needs. Just a couple of comments of things that aren't the problem on this unit, but I wonder about the future reliability if it was used intensively, maybe in a hot environment. Of course, these valves are mounted going down, so the heat is going to tend to accumulate up here. Perhaps that's going to lead to these contacts, these connections being more unreliable. I've just reflowed the solder on all of them anyway, just to make sure. Also, there's a couple of high power resistors here and some diodes, some Zeners, another high power resistor, maybe 1 or 2 watts, probably 2 watts at least. Those are rather close to the board. If I was designing this, I would specify 0.5 centimetre or so at least off the board to allow more heat flow around them. So maybe that's something to watch out for if you see a unit that is starting to look as if there's sort of discoloration on the board. That might be a sign that those resistors were getting too hot. So I suppose I need to give a little warning. Obviously, don't do anything on this kind of amplifier with valves if you don't know what you're doing. The HT for the valves is for 500 volts, can kill you, etc. Particularly around the capacitors here for the HT. They do have bleeder resistors, so they should go down after a few minutes, but best practice always just to check before you touch them. Okay, just be sensible. Thank you.